All right, class, today we're going to go over simplifying radical expressions. I hope everybody's staying warm. If you're not, bundle up because it might get a little cold. First thing I want to talk about is these are some important numbers you're going to need to know for this lesson today. These are perfect squares, and if you see, I got 2 times 2 is 4, and these are the numbers that you need to worry about. All these numbers, they're going to come into play here in a little bit. So if you want to write those down, pause the video and you can write those down real quick because you're going to use them here in a little bit. The product property of square root says this: for any numbers a and b, where a is greater than or equal to 0 and b is greater than or equal to 0, the square root of the product ab is equal to the product of each square root. And basically what that says is, if I got the square root of AB is the same thing as saying the square root of A times the square root of B. Okay, here's an example over here. If I got square root of 4 times the square root of 25, 4 times 25 is the same thing as saying the square root of 4 times the square root of 25. Another example might be if I have the square root of 3 times 8, that's the same thing as saying the square root of 3 times the square root of 8. So that's pretty simple to understand. I hope you don't have trouble on it. Let's get into some examples here. All right, so here we go. Let me get a piece of paper here. So let's look at the first example here. It says square root of 72. And what we're going to do is we're going to do this. We're going to take these numbers that we learned and we're going to find the biggest one of these that divides into 72 evenly. What I mean by that is there's a number over here that's big that goes into these numbers, and we want to find the biggest one. So we go through this list, and I usually start out somewhere down here. Okay, I know right now that our number is 72, so anything above 72 is not going to work, so it ain't going to be any of these. All right, so 64, will it go into 72? No, it will not. Okay, 49, will it go into 72? No, it will not. Okay, I'm just making this easy for you. If you get a calculator, you can divide 72 by these numbers and find out what I'm talking about. 36, will 36 go into 72? Well, let's find out. Let's take our calculators and we're going to divide 72 by 36, and we're going to end up with 2. Okay, so what we do is we write that down. We're going to write that down like this. We're going to write square root of 36 times 2. Okay, which we also know means the square root of 36 times the square root of 2. Now we're going to take and we're going to find the square root of 36, which we know right now, based on this right here, 6 times 6 is 36. So I'm going to write 6, since that's the square root of 36, and I'm going to leave 2 inside the radical. And that will be my final answer, 6 square root of 2. Okay? All right, let's practice another one here. We got 48. Square root of 48. So here we go. If you want to try it on your own, you can pause the video, try this one on your own, then play the video and see if you get it right. So I know right now, based on these numbers that I have right here, okay, that it's not going to be any number below 49. So here we go. Will 36 go into 48? No, it will not. Will 25 go into 48? No, it will not. Will 16 go into 48? Sounds pretty suspicious there. So let's take our calculators. You have a calculator on your phone. I didn't know if you knew that. You take 48 and we're going to divide it by 16, and I'm going to get 3. That divides evenly. Okay, so what I'm going to do is I'm going to write that down. I'm going to go to the square root of 16 times 3, which also means square root of 16 times the square root of 3. And I'm going to take that, and I'm going to solve the square root of 16 is 4, and I'm going to leave square root of 3 inside the radical because it is not a perfect square. So that would be my final answer, 4 square root of 3. Okay, simple enough. All right, let's do some more here. There we go. All right, let's try this. Let's go square root of 80. Man, that sounds hard. Okay, so here we go. Which one of these numbers am I going to use? Okay, I know right now it's got to be one of these up here. 81's bigger than 80, so it's not going to be down here. All right, so will 49 go into 80? Nope. Okay. Will 36 go into 80? Nope. Will 25 go into 80? Nope. Will 16 go into 80? Yes, sir. Sure will. 16 times 5. So what I'm going to do is I'm going to write square root of 16 times 5. So what you end up having is you end up having a perfect square times not a perfect square. So now I'm going to take that, I'm going to go square root of 16 times the square root of 5. Okay. Now I'm going to find the square root of 16, which is 4. And I have left inside my radical, since it is not a perfect square, 5. So I end up with 4 square root of 5. Okay. If you want to try these other 3 on your own, you're more than welcome. We can work them real quick. You can pause the video, work these, and then come back and see if you got them right. Just for fun, because I like doing math, I'm going to go ahead and try this. Okay. All right. I know 50, perfect square, 25 times 2. Square root of 25 times square root of 2. Square root of 25 is 5. I leave 2 inside the radical because it is not a perfect square. And that would be my final answer. 125. I know 125 is 25 times 5. That gives me square root of 25 times the square root of 5. Square root of 25 is 5. Leave 5 inside the radical because it is not a perfect square. So my answer is 5 square root of 5. Alright. Next one. 450. I'd have to go a little bit higher than what I got here on this sheet. So, but I do know what it is. Square root of 225 times 2, which is square root of 225 times the square root of 2. Square root of 225 is 15, and I leave 2 inside the radical. Not hard, not hard. Take your time. Know these numbers. Know these numbers like the back of your hand. Okay? All right. There's some more if you want to try. You can write those down. I'm not going to waste your time and go over them. I know you are all smart and figure out how to do it. Let me change out my paper here. Again, find these numbers. Find these numbers that'll go into these numbers evenly. Now, if there might be a chance where, let's just take one for example. I don't know, let me see here. Let's say I mess up here. Let's just take 32, okay? I know 4 will go into 32. So let's say I do this, I go, that's the same thing as saying 4 times 8. Okay, well, Uh-oh. So I got 2 square root of 8. But here's the problem. You see one of these numbers right here? That goes into 8 also. So I messed up, but I didn't mess up. Because watch, I can do this. Well, that's the same thing as saying 2 times 4 times 2. And I can go 2 times square root of 4 times square root of 2. Square root of 4 is 2. 2 times 2 is 4 times square root of 2, and I end up correcting my mistake. So if you'll do this, if you'll make sure that you pick the biggest number, the biggest one of these, and it takes some time, the biggest one of these that goes into this evenly, and you end up with a prime number inside the radical. Prime number, let's say square root of 8 is 4 times 2. You end up with square root of 4 times square root of 2. 2 is not divisible by anything but itself in 1. That's what I mean when I say prime number, okay? So we're looking for prime numbers. Which one of these times a prime number? That's what I'm saying, okay? All right, I would ask for questions, but y'all don't have any. All right, here we go. Moving on. That's how you simplify radicals. Now, we get to a point where we end up with something like this. Square root of 48 divided by 3. And I know y'all are freaking out because you see fractions and you're panicking, and that's okay. All right, so here's what we need to do. First thing we need to do is we need to break this down to help us out. So here we go. I'm going to go same thing as saying square root of 48 divided by square root of 3. Okay? All right. Which one of these numbers goes into 48 evenly? Okay. It's 16. Okay? So, here's what I'm going to do. I'm going to go 48 is the same thing as saying 16 times 3 divided by square root of 3. Okay? That's the same thing as saying square root of 16 times the square root of 3 divided by square root of 3. Okay, square root of 16 is 4. Square root of 3, square root of 3. Now, here's a great thing. If I got a square root of 3 on the top, and I got a square root of 3 on the bottom, I cancel those, and I'm left with just 4. And that's my answer is 4. Okay? Simple enough? Alright, here's the work for that, and that's what you end up getting. Okay? Alright. I'm going to turn this over like this, and let's do this one. Square root of 7 times the square root of 16. Alright, here we go. Square root of 7 times square root of 16 is the same thing as saying square root of 7 divided by square root of 16. Alright. Square root of 7 is going to stay square root of 7 because it's not a perfect square, and square root of 16 is a perfect square, so it becomes square root of 7 over 4. That's what you end up with. Okay. Alright, let's look at this one. Here we go. Square root of 32 divided by the square root of 5. Alright, so this is under it. Square root of 32 divided by the square root of 25. Which one of these numbers goes into 32? I believe it's 16. So you end up with square root of 16 times 2 divided by the square root of 25 is 5. That's the same thing as saying square root of 16 times square root of 2 divided by 5. I end up with square root of 16 is 4. Square root of 2 is not a perfect square, so it stays inside the radical, divided by 5. And that's what your final answer is. 4 square root of 2 over 5. Okay. Now we have one more example. All right. Let's look at this bottom one. Let's look at this one right here. Okay, we get to a point here where square root of 15, none of these numbers are going to go into 15. Square root of 3, none of these numbers are going to go into 3. Okay, but, so you think you're done, right? Well, you can't have a radical in your denominator. So what you must do is you must take and you must multiply the radical that you have in the bottom, just like so. All right? Everybody understand? Then you multiply that out. 15 times 3 is 45. The square root of 3 times the square root of 3. Let me give you a hint. Anytime a radical multiplies by itself, the answer is the number inside the radical. Just like so. Okay? Now, which one of these numbers goes into 45? 9 does. So I'm going to go, that's 9 times 5 divided by 3. All right, I'm going to go down here. I got square root of 9 times the square root of 5 divided by 3. Square root of 9 is 3. Square root of 5 is not a perfect square. Divided by 3. 3 in the top, 3 in the bottom cancels. So I'm left with square root of 5 as my final answer. Okay? All right, now what I want you to do is I want you to try and do this one. Pause the video. You do this one, and then come back and unpause the video and watch the video. Welcome back. All right, so here's what I'm going to do. Can't have a radical in the bottom, so I'm going to multiply by what's in the bottom and multiply that same thing for the top. So I end up with 3 times the square root of 3 is 3 square root of 3. Square root of 3 times square root of 3 is what's inside the radical. 3 in the top, 3 in the bottom, cancels. And what I'm left with is square root of 3. Okay? So, remember, you can't have a radical in the bottom. Remember these numbers. Okay? If you got a radical in the bottom, you multiply by the radical times the bottom and the top. Then you simplify. If you don't have a radical, if you have one of these for an example, and you find the biggest number, the biggest number that goes into this evenly and with a prime number, change it, and you end up with square root of 4 times square root of 2. Square root of 4 is a perfect square, it's 2. Square root of 2 is not a perfect square, it stays square root of 2, and that would be your final answer. Okay? Hope everybody stays warm. You come on tomorrow again, get another video. I will leave you some more information here shortly.